Hi, my name is KUGANESHINI, and today I am going to present to you about ocean ion fertilization. So, what is ocean ion fertilization? It is the addition of ion nutrient either by naturally or artificially into ocean waters. Scientists made a discovery about the carbon dioxide level in the atmosphere during the last glacial maximum by looking at the Arctic and Antarctic ice cores. It was revealed that the carbon dioxide level during the LGM, which was about 30,000 years ago, was only at about 180 ppm. The main objective of OIF is to increase the amount of available ion nutrients in high nutrient, low chlorophyll water region to increase the rate of photosynthesis and atmospheric carbon dioxide absorption. So by looking at the figure below, you can see the effect of ion nutrient on the amount of dissolved inorganic carbon in different layers of the water. So when the amount of ion nutrient increases, the amount of dissolved inorganic carbon also increases. So the OIF experiment was conducted in several regions of the world's ocean, including Equatorial Pacific, Subarctic North Pacific, and Southern Ocean, which are high nutrient, low chlorophyll water regions, and North Atlantic, which is low nutrient and low chlorophyll water region. Why they are chosen to do these experiments? It was because it is to observe the photosynthetic and carbon sink rate at both high and low nutrient conditions. So the relationship between ion nutrient level and the carbon dioxide level in the atmosphere is as follows, which are a water region with high macronutrient level and high ion nutrient level has higher photosynthetic rate and absorbs more carbon dioxide from the atmosphere. However, a water region with high macronutrient level but low ion nutrient level has lower photosynthetic rate and absorbs less carbon dioxide from the atmosphere. To date, exactly 13 OIF experiments have been done in the ocean waters. 12 of them were done in HNLC water regions and only one was done in LNLC water region. 8 out of 13 of the experiments had unsuccessful findings due to certain limitations, which are short time periods in experiments which are insufficient to observe the change in the photosynthetic rate of the phytoplankton properly, low levels of micronutrients and macronutrients, which also inhibited the photosynthesis of the phytoplankton, the sinking of phytoplankton to lower water columns in ion-fertilized water regions, reduced sunlight due to storms that lowered the photosynthetic rate of phytoplankton, lack of carbon export flux measurement in the mixed layer depth water column, and accidental addition of dissolved silicate into the fertilized phytoplankton patch through mixing of ocean currents, which encourage the diatom bloom instead of the ion nutrient. So, are these experiments successful or not? Well, almost all of the experiments were unsuccessful from achieving increased primary production using ocean ion fertilization, except for European ion fertilization experiment. Some of the OIF experiments, such as ION-X1, were unsuccessful because the photosynthesis and primary production rates did not increase significantly and remained low primary productivity. So, what are the improvements that can be implemented in the future OIF experiments? We can carry out the experiments in the center of an eddy structure of a water region so that the phytoplankton will not get eaten by the grazers and the available silicate is also abundant there. Secondly, is to extend the period of time of observation, which is about 40 days, to get a complete and proper view of the development of primary production during the experiment. Thirdly, inject the ion infusion more than once to supply the phytoplankton with enough ion nutrient and respond to the ion addition. Fourthly, is to detect the ion fertilized patch using both physical and biogeochemical traces. And fifthly, use autonomous technologies and transmissometer to accurately estimate the carbon export flux at and below the mixed layer depth of water. And last but not least is to monitor the decrease in oxygen and the production of greenhouse gases using autonomous technologies. Finally, these are the references. That's all. Thank you.